Okay, in this video, what we're going to do is that we're going to take the properties that we discovered in the last video of the special right triangles and apply them to solve for sides of the special right triangles in various examples. So the first thing we do, and this guy right here is a 45, 45, 90 triangle in the left-hand corner here, and we want to solve for y and we want to solve for w, okay? So what we can do is that in order to knock that out, we can draw a template triangle here, and the template triangle is going to consist of what we learned in the last video. So in a 45, 45, 90 triangle, we know that the two smaller sides, okay, are going to be the same length because it's an isosceles triangle. And we discovered through patterns that the hypotenuse is always going to be n square root of 2. So those n's could be any value, okay? And what we're going to do is that I'm going to match them up. So what I say match them up, just when they correspond to the left-hand side, like this 4, I'm going to match that up to this n over here. So I'm going to go then n equals 4. Then I'm going to match up another side over here, and like that, and I will say n equals w. And then finally, I have the final side over here, which is going to match this direction, where I would have n square root of 2 equals y. Okay? So what we want to do is that we want to, as soon as we get some information, seeing what n is as a number. And in this case, we end up with n equals 4. So when we know that that was already given to us, and that's what we're looking for. We're looking for something that we could solve for n as a number, okay, and not have two variables like n equals w or n square root of 2 equals y. So since n equals 4, all the other n's are going to turn into 4s. So for example, this says n equals w, so I would say 4 equals w, or w equals 4, so I know that this side is of length 4. Okay? And likewise, if I were to look at the next part right here, I would have n square root of 2 equals y. I know that n equals 4, so I would go 4 square root of 2 equals y. So I know that this side would be 4 square root of 2. Okay? So that's one of the slickest ways to use a template triangle and matching things up. Let's try this again, except with a 30, 60, 90 triangle. Okay, so the first thing we want to do is draw out our triangle, and we want to make sure that we have things in the right place. And we said that the shortest side, which is across from the 30-degree angle, is going to be n. The hypotenuse is going to be 2n. And the middle side, or the middle length side, is going to be n square root of 3. So what we do is that we match them up, and let's see how we let's see what shakes loose from there. Okay, so I have 2 and n right here, so I got n equals 2. Then I have y equals 2n, so 2n equals y. And then finally, I have over here w and n square root of 3. So I'd have n square root of 3 equals w. So now I look for the n that I can solve for. That means is that it doesn't contain a statement that doesn't contain two variables. This is the correct statement that I'm looking for, n equals 2, and it is given by the purple part right here. Now that allows me to solve for the sides w and y. So now all the n's turn into 2's, and so I would get, this is going to turn into a 2, and so I'd go 2 times 2 equals y, so y equals 4, double the length. And then the n in front of the square root of 3 for w is going to be 2 square root of 3, well, that equals w, so I know that this is going to be 2 square root of 3. Okay, so that's how you do some easier examples, and we're going to take a look at some ones that have a little bit more arithmetic to them in the next video. So see you there.